Um, Technically, there was an assignment due on Friday. It looks like I had a bunch of people pass it in. Those who passed it in earlier, it's already been marked, and you can look at it under.
Oh, I forgot about that.
No, it's hey, don't worry about it.
Well, I got it done. It's just I just handed it in.
No, no
I don't even
worries.
know. I don't even know where my pre-calc thing is.
No, no, no. It's not something I'm like, oh my gosh, Brady didn't hand it in. Zero, which absolutely makes no sense. But there's I've
Yeah, that's what some teachers are like.
even now
Yeah, pretty much. They want. There's a teacher that wants it on the due date.
for what subject?
Physics.
Yeah, well, one of the emails that came out last week from Zoe Watson was about like being reasonable and all of that. And it's like, yeah, I want to return things. I'm not giving you answers in it. So it's not like I'm saying, oh, here's how you do this question, and I'm not going to post like a solution set because it doesn't really make a huge difference. If people have questions, they can ask them, and different people have. Um, if you're having trouble with submitting it through here because of internet issues, you can email it to me. It's a little more complicated. I mean, it just means I have to reply to a whole bunch of emails, which is kind of the joy of this setup that I don't necessarily have to reply to a whole bunch of emails. I can just type it all in a little box. But if you have to, so be it. I'd rather get them. Oh, I suppose I should. Started recording, so I should share a desktop. Um,
Can I ask you a quick question before I take a
sh-
picture of this?
sure.
So for 6a, there's tan square x,
Yeah.
and so I have sine square x over cos square x.
Okay.
So what would I do after that?
I don't have 6A in front of me. Um, if you're worried about it, send me an email after, and I'll look the question up and go through it. I apparently thought I had gone through and done some of the transformations stuff. I wanted to move on because on Friday I went through a bunch of those. Doesn't need to be there. I can't remember if I put answers up. I will do those.
Inverses.
Yeah, we'll talk about that. Is there any questions on this kind of review bit? I mean, we can't really do 8, but I think a lot of it that you would have to do for the assignment is fairly straightforward. Um, but inverses we've kind of already sort of looked at in terms of what they are. Um, we haven't done them formally, but there's now oh, now it's sharing. Oops, sorry. Uh, Friday we did this RF 1 to 4 review. We went through some of that stuff. These are technically the things that we need to be able to do, and those are the sorts of things that are on that assignment. Which the more I think about it, I should have shortened a little bit, but again, I have to put a due date because I have to put a due date. I'm not super worried about them. If other people are, well, that's that those particular teachers. I this is we're in unknown territory, so if all of a sudden everything shows up on the last day, yeah, it's inconvenient for me, but the whole setup's inconvenient for everybody. So I wanted to quickly or start looking at inverses um, in terms of functions, tables of values. Some of these are going to be quick. Apparently, oh, yeah, I know what I want to do there. Um, oh, good. I had, oh, there, okay, it's still there. Why is it not showing up? Like, there's the equation. Close. No. We'll start again. I'm sorry. Actually, I can just do it this way. No. So fundamentally, or one of the things we talked about, there we go, with reflections was we reflected in the x-axis, changing the y-coordinates. We changed the x-coordinates, reflecting in the y-axis. We talked about reflecting in the line y equals x. Sorry. And that fundamentally, when we looked at a mapping rule, was our x and our y coordinates switched places. And in terms of functions, we haven't talked about these before. In terms of math, we've talked about an inverse multiple times. The inverse of addition is subtraction. The inverse of squaring something is square rooting. The inverse of taking the cosine of an angle is, just because I have to do this, the inverse cosine. We sometimes shorten it or talk about it as second function because that's what it usually is on a calculator. But fundamentally, it's the inverse. It's the opposite operation, which is switching the x and the y. Um, and technically, in terms of a graph, switching the domain and the range. So I've got the first thing. If I gave you the line y equals 2x minus 6, 1, 2, 3, 4, 5, 6, up to over 1, we can plot that. That's a function because it keeps going on and on and on forever. Would look something like that. If we do the inverse of that, oh, I got to change color because I did that. The inverse of this equation is x equals 2y minus 6. The first step for an inverse is that. And none of you are in 12b because, well, that just doesn't make any sense at the moment. Um, there's a different type of function that we call a reciprocal function, um, which is slightly different. And I made the mistake when I was in grade 11 when it's like write the inverse, and I totally blanked that it's just switching x and y. So we can look at this in kind of two ways. The line y equals x is about there. We could generate a table of values, which we're going to look at in a second. But I'm going to look at a couple of points and just invert them. So if I look at this point here, 1, 2, 3, 4, over 4, up 2. It's now going to be over 2, up 2, because, oh, apparently that's green. I want it red. Uh, this one is over 3, up 0, so over 0, up 3. Over 2, down 2 is back 2, up 2. 1 and negative 4 becomes negative 4 and 1. So we have this secondary line, oh, because the colors are going to get confusing. Let's change that to something we can see. Come on, brain. Bright green. So there's our reflection line. There's our y equals x. Now if I draw the graph of these points, yeah, they may intersect. That was supposed to be red. I'm not sure how that happened. It's Monday morning. Hopefully everyone enjoyed the wonderful sunny day on the weekend. And it's kind of sort of snowing here. So the red line here is the inverse. It's the opposite sort of thing. We can write an equation for this, which one of the things we need to do with an inverse is to be able to write an equation, which is fundamentally algebra. And the lines could potentially intersect. They're going to intersect, whoops, at this point about there. It's kind of hard to tell just because of my poor graphing skills. That point there is where they cross or where they're both on the reflection line. So when we talk about an inverse equation, we have x equals 2y minus 6. But we don't want any equation in math in terms of x. We want to rearrange this for y because we want it in the term of y equals. That's how we generally, in function notation and whatnot, put an equation. So if I rearrange x equals 2y minus 6, the first thing we would do is add 6, x, whoops, plus 6 equals 2y, and then we would divide everything by 2. So I would have y on this side. X over 2 is a half x. 6 over 2 is 3. And then we would say y equals a half x plus 3, which if we look at this one, we have a y-intercept of 3, and the slope is up 1 over 2. And then we get that point 2, 4, 6, and 6. And this is the equation. If f of x equals 2x minus 6. When we talk about an inverse, we're going to talk about f minus 1 of x. That's our function. The inverse function is a half x plus 3. Coincidentally, this is just a flip and changing the sign and all of that. Some people also will write this as y minus 1. The negative 1 up there is similar to cos minus 1, sine minus 1. We don't really do that for radicals because we do that with roots. So really, all we've done is looked at changing our x and our y coordinates, reflecting it along that line. So we can, if I have a table, whatever this function is, I don't particularly care. The inverse is f minus 1. All we do is, well, if that point is negative 3, 5, the inverse is 5 and negative 3. If this point is negative 1 and 7, the inverse is 7 and negative 1. 0 and 2 becomes 2 and 0. Negative 4 and negative 8 becomes negative 8 and negative 4. So we're flipping our coordinates, which that's the same idea as what we did with the transformations in terms of just random points, but we can look at a graph. Well, we've done a whole bunch of work in 2 courses on y equals x squared. Negative 2 and 4. Negative 1 and 1. 0. Ooh, that would be bad. 0. 1 and 1. Stooge. 2 and 4. So if I'm going to go down here and plot those, and we all should be fairly familiar, and I can even do 3 and 9. Now comes the fun part, trying to connect these points. Because Drawing graphs on this is horrifically bad. Try to do it this way. So this is the graph of y equals x squared. So you've done that since, I don't know, the second week of September. When we talk about the inverse, we have x equals y squared. I can build the table of value by saying 4 and negative 2, 1 and negative 1. Well, 0 and 0 doesn't change. That's called an invariant point because it doesn't switch. And 4 and 2. So we have a table of values. Technically, I can say 9 and negative 3 and 9 and 3. So I'm going to start at, well, 0, 0 doesn't change. 1 and 1 doesn't change, but this one goes over to there. We have over 4, up 2, over 4, down 2. And we basically have flipped the parabola. We've reflected it in y equals x. So it's along that reflection line right there. Oh, now let's see how I can draw. Kind of, okay, maybe. So we have y equals x squared. The red one is x equals y squared. Well, if we want to get this in terms of y equals, how do we get rid of a square? We take the square root of both sides. The square root of y squared is y. The square root of x is the square root of x. However, because we have this squared part, we have the positive and the negative. And that's the same idea as the plus and the minus in the quadratic formula. And we talked about that in radicals. Oh, sorry. Oh, there, that's better. So in this case, the y equals positive root x is that branch there, because this is all the positive ones. And then we have y equals negative root x. When we have exponents, we can have this, because technically that graph is not a function. It fails the vertical line test. So it's actually in two kind of bits. And that's just because we have a negative, it's reflected about the x-axis. So when you take the inverse of a function, you may not necessarily get a function, but we have, that is the inverse there. And we're, well, 1018. We're going to look at some algebraically, and then we have, yeah, quadratics are kind of the easier thing to look at. And this leads into our next topic, which is radical functions, and where we go from there and transforming them. So it's kind of an intermediate step. So the inverse of this is x equals y squared minus 4. Add 4, add 4. I'm just going to, whoops, I'm going to keep the colors consistent. Y equals y squared equals x plus 4. All I've done is flipped it to make it look a little nicer. Now we need to take the square root of the whole thing. So we have y equals plus or minus the square root of x plus 4. In this case, we have we started with a vertical translation because x squared, that's outside of the x part. So that graph would be something like that. Now we've got x plus 4, the inverse is going to be have a horizontal translation of something along those lines. So the translation switch. So that was a vertical translation. So we went from a vertical translation to a horizontal translation, which makes sense because we're interchanging x and y. So in the next one, the inverse, and we'll say y minus 1 of this. So we would have x equals y minus 6 all squared. We have a horizontal translation. This one has a vertex at 6 and not 6, but 6 and 0. And when we do an inverse, well, the first step we have to do here, because that 6 is in the brackets, is get rid of the square root. So we have y minus 6 equals plus or minus the square root of x, and then y equals plus or minus the square root of x plus 6. So this one we went from a vertex over here. Now we have our vertex up there. You can build this with a table of values. You can do it algebraically. And the last one we're going to look at is the combination of the two. Y equals x plus 4 squared plus 3. This is a graph you would have done with Mrs. Parley if you had pre-calc 11 last semester. So I'm going to graph this first. Let's go back to blue. So this one has a vertex of negative 4 and 3. There's no stretch. There's nothing funny. So negative 4 and 3 over 1, up 1, over 1, up 3. And I can't really put anything. Whoa. Nope. There. So that's nothing abnormal like that. That could have been a question on your exam or any random test last term. If we had an exam, I would say graph y equals x plus 4 squared plus 3 and give you a mark because it's a question that should only take 25 seconds. X equals y plus 4 squared plus 3. X minus 3 equals y plus 4 squared. The square root of x minus 3 equals y plus 4. And then y, the inverse of the function, plus or minus the square, whoa, let's not get ahead of ourselves, x minus 3 minus 4. So we're going to look at graphing these later this week or next week. But we can graph this red beastie using our old-fashioned friend, the line y equals x. Something like that. So negative 4 and 3 becomes 3 and negative 4 and 3 becomes, yeah, that's negative 4 and 3 becomes 3 and negative 4. Why am I having, that's negative 4 and 3 becomes, yeah, I'm overthinking the signs. That goes to there. Negative 3 and 4 goes to 4 and negative 3. Negative 5 and 4 goes to 4 and negative 5. And then we can kind of just use that pattern. And there is the graph of that particular inverse. I think I left these in there. These are Mrs. Legier's super charts. I changed, oh, I don't know if I left that one there. No, that's just an illustration. The positive square root of x is the top arm, and we'll get to that in radicals. Um, like that's inverses in a nutshell. I also put this up here because, well, it's 1025. Um, of course, this is going to take ages to open. We are, where's my recording thing? I just want to double check and make sure we're recording. We're up to 16, the regulars. Those of you who can get up in the morning. Although on a dreary day like today, staying in bed might have been more fun. So the second one that says 3, um, what type of reflection, what do you do? These are ones you can practice. We'll go over them tomorrow. Determine whether your following graphs are an inverse, justify your answer. We'll look at that tomorrow. Um, and that probably will be it for inverses. Uh, while I'm hiding in the basement, and hopefully Kate went to sleep. She had a little bit of a. I'm going to open up that other one, and I'll kind of fill out the answers so we can all have those to look at because there is our second assignment is in there, I think. I'll probably tack questions about inverses in the other part. Yeah, the second one is in here. Oh, my mother is sending me messages. Um, and like I said, if you're watching this later, the assignments have a due date in one sense, but they're not allow late turn-ins. I'd rather get this 3 days from now, and well, this one is due on on May 4th, which is Star Wars Day. I'd rather get something late than not get it at all.
That one there isn't a new one, is it?
The second one that's up in there,
Yeah.
I put it up there last week.
Okay, but not today.
No. The only things I added today were the 2 files for inverses. So tomorrow I'm going to go through those inverse things. If you want to look at them and try some of them um, ahead of time, you can. If you want to just sit and wait and watch, um, you can do that as well. And then we have to go into the next section is on actually radical functions, and we'll be graphing them and talking about radicals because a lot of the stuff in 12a and 12b in terms of, well, we talked about transformations, we talked about trig. Having done it, I think even I would have done the transformations before we did trig, so it would have made everything after that is about, well, graphs and manipulating them. We're going to talk about radical functions and graphs and manipulating them. And then we get into exponentials and logs. And your big assignment for 12B is something called the function toolkit, because if you're taking calculus, you have to have some idea about the shapes and behaviors of the common functions. And that's really what pre-calculus is about, is getting you prepared for calculus. But that's all I wanted to do today. If anyone has any questions about the other things, I'll post this in a bit, and I will. Um, what I did see is going to seem to make no sense, but logically, I will finish this and post the end part of that. Tomorrow we'll look at that third part or at the next file in inverses, uh, and we'll carry on from there. Probably the next assignment will have inverses and radicals on them as well. So if there are no other questions, I will sign off for the day and let you guys, well, I would say enjoy the day, but it's cold and wet and dreary, and just stay inside and stay warm.
Mr. McKay,
Yes.
I have a question. So why did you put the like y with the -1? I didn't really understand that.
So that's just to denote that, like when you have the two graphs, one is your original function, the y minus 1. One is the inverse function.
Okay.
So it's just like that cos minus 1 when we did trig to find an angle. It's just to show that it's the opposite of the original.
Oh.
Okay?
And are we gonna go over the practice questions tomorrow? Like you'll have them like on a page so we can like correct our own.
For like the inverse one,
I think so.
the inverse one, this one that I just clicked on, yeah, I'll go through all of that because there's really not a whole lot to inverses. I'll go through and do that one tomorrow because
Okay, sounds
it's
good. Thank you.
okay. Anything else? If not, I'll let you all go.
Thanks, McKay.
No problem. Have a good day.
Yeah, you too.
Thanks.